Okay, to wrap up this lesson, I wanted to cover these final two problems that hopefully will help you when you come to the last 6 problems of the assignment. So 2 examples, and I'm hoping that that'll provide enough help for you. So it's a 2-part answer. Find the vertices and the asymptotes of each hyperbola. Well, remember, vertices indicate the points where our 2 parabolas are going to cross a particular axis. And in letter A, we're only going to be crossing the x-axis. And where we cross is, again, vertices, and that will be the square root of a squared. And remember, for hyperbolas, a squared is always the first denominator, and b squared will always be the second. So the square root of 1 is just 1. So my first part, the answer to the vertices, I'm going to be crossing the x-axis at both positive 1 and negative 1. So I can just state vertices in this way. So that's the answer to where I will be crossing the x-axis, aka what are the vertices. Okay, so for asymptotes, remember these are lines that basically our graphs will always approach but never touch. So we've been drawing these asymptote lines using that central rectangle. How do we come up with the equation for these lines if we are not looking at the central rectangle and all we're looking at is the equation for the hyperbola? Well, I'll show you a way. This is really not bad. I'll show you a way to come up with that equation. Remember, these are lines, so you're thinking y equals mx plus b. Now we'll tell you this, since in this lesson all of our hyperbolas are centered at the origin, so in each case the b, the y-intercept, is just going to be 0. So really it's just an exercise in how do I find the slope to plug in for m to complete the equation. Well, remember, slope is just the change in y. This symbol here is delta, the Greek symbol delta. Always in math, or pretty much in any case, it means the change in. So slope is the change in y over the change in x. And I put this up here just as a reminder. Remember, if slope is always y over x, change in y over the change in x, then that's kind of a clue as to how we're going to find the slope of these asymptote lines. Okay, so let me see if I can steer you in the right direction here. First of all, I notice in this first equation, this is a little bit unusual. We haven't seen anything like this yet, where there's a coefficient other than 1 in front of y squared. So I'm just going to write this in an equivalent way. It's not like I'm going to divide everything all the way across by 4. I'm just going to use a different way of representing 4 times y squared, because true standard form should have coefficients of 1 in each case. Well, multiplying by 4 is the same thing as dividing by 1/4. So I'm not really solving for a variable. I'm not changing. A lot of times we divide all the way across because we need to make this number become 1. I just found another way of expressing this equation so that now my coefficients for x squared and y squared are both 1. Okay, so with that said, my a squared is still 1. Don't need to write it, but I'll go ahead and write it. A squared is 1, and b squared is 1/4. Okay, remember, dividing by 1/4 is like multiplying by 4. Okay, so just keep this in mind when you're trying to come up with the slopes for these asymptote lines. Think y over x, and just take the b, or the number that's underneath y squared, in this case b squared, find out what b is. And the square root of 1/4 is 1/2. And then a, the square root of a squared, which is a, is going to go underneath. You always, I'll put it in some non-mathematical terms for you. Whatever the denominator of y is, if you go back again and remember the definition of slope, y is always on top of this fraction. So whatever the denominator of y squared is, the square root of that will always be on top. And the square root of x squared denominator, which is in this case going to be a, will always be on bottom. Okay, so it's like this. Since there are two lines, remember we made an x with those two asymptote lines, it would be plus minus 1/2 x. The slope of this that we came up with is 1/2. So to finish that off, I would say the equation to represent my asymptote lines would be y equals, and we came up with the slope, which is plus minus 1/2 x. So to recap, take whatever y's denominator is, put it on top as the square root. Whatever x's denominator is, put it on bottom, square root. And that will give you the slope of the asymptotes. And again, you won't have to worry about it in this lesson, b being anything besides 0, because everything's centered at the origin. Our two lines should cross at 0, 0, y-intercept 0. Okay, now that we've seen one, let's try another one. This one is not in standard form because it doesn't equal 1, so I need to divide by 144 all the way across. So I'm going to get y squared divided by 16 minus x squared divided by 4 is equal to 1. All right, so x squared, y squared have coefficients of 1. The equation equals 1. All right, so let's first knock out the vertices. Well, this time I'm crossing the y-axis. So in rough sketch form, it's going to be two parabolas that do this. And where they cross will be the square root of 16. And so positive 4 and negative 4. So my vertices are going to be 0 plus minus 4. Okay, so with that said, now let's see if we can find the equations. It's really two because one positive slope, one negative. What would be the equations for the asymptote lines? Okay, well remember, keep it straight, y over x. So you're going to take the denominator for the y squared, the square root of that, and put it on top. Square root of 16 is 4. And the square root of 4, which is x squared's denominator, will go on bottom. Okay, and then remember it's two different lines, so you're going to do plus minus. And so to simplify this, we would say our two lines are y equals plus minus 2x. All right, so the thing that some people miss in these problems is they just always do whatever b is over a. Okay, but it really depends on where y is and where x is. You use the y denominator on top always, and you take the square root of that. And you always use the x denominator on bottom, because that's technically what slope involves, the change in y over the change in x. Okay, so I hope that makes sense. It's a two-part answer here. Work through these and see if you can get them on 39 to 44. And if you have any questions, feel free to let me know.